For the first time, scientists have watched water molecules split apart in real time, forming hydrogen and oxygen. But just before breaking apart, the molecules did something completely unexpected. They flipped 180 degrees. This tiny flip actually takes energy, which helps explain why splitting water requires more energy than the theoretical calculations predict. Understanding this process better could lead to more efficient ways to produce clean hydrogen fuel, potentially making it cheaper and even useful for generating breathable oxygen on Mars. Hydrogen has a lot of potential as a green energy source. It can power trucks, cargo ships, and even serve as the only real alternative to fossil fuels in industries like steel and fertilizer production. And when it burns, it doesn't release carbon dioxide, just water. The problem? Producing hydrogen fuel takes a lot of energy, making it expensive. To meet global energy needs, we'd have to produce about 322 million tons of hydrogen fuel every year. But in 2023, we only produced around 97 million tons, and most of it came from fossil fuels. On top of that, making hydrogen costs anywhere from 1.5 to 6 times more than producing fossil fuels. To create hydrogen fuel, scientists use electrolysis, applying voltage to water through an electrode, which breaks the water molecule into hydrogen and oxygen. The process works best with a catalyst, and one of the best is iridium. But there's a catch. Iridium is rare on Earth, and mostly comes from meteorites, making it both scarce and expensive. Even when using iridium, water splitting is still less efficient than expected. Theoretically, the process should only need 1.23 volts, but in reality, it takes closer to 1.5 or even 1.6 volts, adding extra costs and limiting large-scale production. To figure out why, researchers placed water on an electrode and used laser light to track how the molecules moved. When they applied voltage, they saw the water molecules flip rapidly, so that instead of hydrogen atoms facing down towards the electrode, oxygen did. Why does this matter? Electrodes are negatively charged, so hydrogen atoms carry a slight positive charge, so they naturally want to face down. But in that position, the oxygen atom can't easily transfer electrons to the electrode, blocking the reaction. When the voltage gets strong enough, the molecules flip, allowing oxygen to connect with the electrode and making the reaction possible. By measuring how many molecules flipped and how much energy it took, researchers found that this movement is likely an unavoidable step in splitting water. But they also discovered something interesting. Higher pH levels made the process more efficient. Studying this flipping effect further could help scientists design better catalysts to make water splitting easier and more cost-effective. It could also lead to a better understanding of how water behaves at surfaces, which is something researchers still don't fully understand. If scientists can develop catalysts that make this flipping process smoother, we could finally make large-scale hydrogen fuel production practical and affordable. And that could be a game changer for clean energy. That's it for today, and thank you for watching. And as always, have a Voltastik day.